Okay, hi guys, welcome to the workshop. So we're going to be recording this and uploading it on YouTube. Okay, this is the first workshop for our Datathon, which is Intro to R and Basic Data Analysis, which we're going to be going over in the second part of the workshop. So first, if you're new to RStudio, this is a link to download it. And in order to run R, you kind of need to download the R version and the latest version of RStudio. You have to work those two together. So yeah, if you haven't done that already, I highly recommend downloading it. Okay, so let's go over the basics first. I'm going to walk through the interface, the basic operations, objects and vectors, and then strings and integers. I'll be going over that like slowly in the next couple of slides. So first, I just wanted to go over like the basic interface that R has. In this picture, we can see that there's a console in which you would type out your code, and when you click enter, it runs the code for you. So if you, let's say you want to create an object, you would type out that object in the console, and that object would be saved in your environment on the upper right corner. The environment saves any data set you import, the objects you create, variables you name. And then the bottom right corner is where all the plots are, the files, and the help section is if you need any help with certain R code, you could go to that section, search up the code you want, and it gives you an explanation of what the code does and how to use it. Okay, so I'm now going to be going over the objects and types. We can start with the basic strings. So a string is basically a set of characters. So for example, hey, what's up? This is a string. In order to declare a string in R, you would need to put it in quotations. And that's how R will kind of know that this isn't an integer or this isn't any like number, it's actually a string. Next we have Boolean values, which is just true or false values. Just like you have binary 1, 0, 0 indicating false, 1 is true. Similar thing in R if you know Python or any other coding language. If you don't, basically Boolean is just true or false values. So it would be if you ask, is A greater than B? And let's say A was 10 and B is 9. In that case, your answer would be true. And so this is a Boolean value. Your integers are basic numbers, 1, 2, 3, 4. And then we have vectors, which is essentially a list. And in order to declare a vector, you have to embed the C before you write out your list of numbers. And here you can see that it says X, and then there's an arrow pointing to the X, which means that you're creating an object called X that you're declaring to be this vector of numbers that are 1, 2, 2, 2, 3, 3. So you can, if you look at the bottom right corner of the slide, I posted a picture of the environment. So I declared a variable named die, and I set it from the numbers 1 to 6. Now, oh, sorry. You can see that that variable is being represented in the environment on the right-hand side, like I said earlier. Now from vectors, we can move on to matrices. Matrices are just more complex vectors. You don't really need to know that. It's just like some extra information I'm just putting out there. And if you want to declare that, you would do it in the manner as written on the slides. There's also basic operations you can perform in R. So for example, just like how you would normally do 1 + 1, you could also add the declared variable with a number. So if I declared a variable die, as I did from 1 to 6, I can subtract that. I can subtract 1 from that, and it gives me these values. I could also divide all the values declared under the variable die by 2, and it gives out a set of these variables, these numbers. I could also multiply that variable by itself. In that case, it would basically just give the square root of each number declared in the variable die. Okay, so I could go over some basic functions we have. R has a set of functions already within the program. There's mean, which is basically just the mean of whatever you want to put in there. In this case, I did the set of numbers from 1 to 6, and the mean is given right there. You could also do the mean of the variable I declared earlier. So here I declared die to be from 1 to 6. And it gave me the mean to be 3.5. I could also round this mean. So instead of giving me 3.5, R would round down to 3. Mostly because it's just, it rounds down to an integer. And then you could also write your own function in a similar manner. For the course of the Datathon, I'm not sure if you're going to need that, but if you want to look more into it, you could definitely check this out. This is how you would create a basic function. You would use the function and declare, you would use these brackets and declare what you want to say inside, and then close it up and name your function as something so you could use it in the future. Okay, a quick tip is, instead of using the R console and always like copy pasting it, if you like forget a code you used, use the R script in that RStudio has to offer. You could just type out all your code, and there's a run button at the top of the R script, which will just run all the code that you have generated. Some packages that we recommend are ggplot. We did the ggplot workshop earlier this semester, so I highly recommend checking that out. We showed basic visualization plots in ggplot. And we have all the code written out there, so I highly recommend taking a look at that. If you want to download any package, actually, you would just do install.packages, and you would put the package name in quotations like so. And in order to declare that you want to use this package for your code, you would just say library and then the package name inside. This is just some extra stuff. Again, just like a basic introduction and for you guys to get an understanding of what loops are. So first I will go through for loops and while loops. So a for loop repeats a chunk of code many times. So for example, in this for loop, I said for the value in this list of strings, I said to print one run. So it's just printing one run multiple times after I ran the loop. Similarly, the while loop actually runs a chunk while a certain condition is true. So you would say while whatever condition you want is true. For example, while A is greater than B, and you would put whatever code you want. So I would say while A is greater than B, add 1 to A, and it will just keep adding 1 to A as long as A is still greater than B. Obviously, declare the values of A and B first so that the loop knows what variables it's supposed to refer back to. But yeah, these are the two basic loops I think that you guys should know. I don't know if it'll be very useful for cleaning data, but it's definitely useful in the future, and if you guys are planning to take Data 101 or Stat Inference.
All right, cool. I think it's my turn. So let's talk about the data. All right, so as you guys hopefully remember from yesterday, and all the Discord messages we're sending, the theme of our data set is brain stroke prediction data set. So, we have some basic column headings and stuff to go over, but more than that, because you guys can look at the columns and stuff by yourselves, I also kind of want to talk about what we're looking for as you go through the data set and you make your presentation. So, Tom, you want to go to the next slide? Cool, thank you. So the first thing I want to talk about, pretty simple, but what is qualitative versus quantitative? Cut to the chase. Qualitative obviously is something that you observe, right? And quantitative is something that's numerical, you can count it. It's like good hard data instead of, having like a different kind of range of, oh, this is more red than this or something like that. All right. Next slide, please. All right, so in our data set, qualitative aspects are things like the job they have, if they're married, when they got married, if they smoke, their gender, etc. And quantitative is things like the glucose measurements, their age, and their BMI. So these things matter because when you go to see like, oh, is there a correlation here? You might try and test for p-values. And sometimes different p-value tests, you can actually use different tests, like a Shapiro-Wilkinson test or something like that, to see if your p-value is still true, given, for example, the qualitative data. All right, next slide. All right, type in the chat, yes or no. Does correlation equal causation? Thank you, Tommy. And thank you, Luke. Yeah, no, it does not. Correlation does not equal causation. So Tommy, can you click, but only click once? To go to the next slide. Yeah, okay. Reasonable versus unreasonable and using sources. All right, you can go to the next slide. All right, so Sam observes that most cats are born with whiskers. You can click again. Sam concludes that everything with whiskers must be a cat and that cats must have whiskers because it makes them cuter. Next slide. Is this reasonable? No, this is not reasonable. Next slide. Similarly, when you make claims about your data set, make sure that you cite your sources. And you can kind of even go a step further than this and cite your sources from your data. So for example, if you're going through your data set and you notice that, I'm completely making this up, by the way. If you're 33 and you live in a rural area and you are married and you smoke a bunch and you're a dude, you're 100% gonna have a brain stroke. Yeah, like maybe back your sources up with that. Maybe it's possible that people in rural areas might have higher complications with strokes and things like that due to not having hospitals in the area. And I say that because there are a gazillion papers on that exact subject. So if you say, oh, we noticed a link here based on this data set, and we went and we looked, like in PubMed or on Google Scholar or something, we found that this is actually a thing in the larger scheme of America. Can go to the next one. Wink, wink, nudge, nudge. That will look really, really great in your presentation when you go to present the data and see what you found. It's great, wonderful if you find predictions in the data set. It's like 20 times better if you back them up. So some good sources are peer-reviewed papers. So that means papers that have been drafted by a doctorate and then reviewed by another doctorate to basically say, yes, these guys are legit. Medical journals, sites that end in .edu. Those are going to be all of the university sites. So I know Harvard releases a bunch of really cool medical papers on their sites, and those always end in edu, but they're kind of written more like blog posts, things like that. Bad sources are from things that show obvious bias, like strokesaremade-up.net. And, maybe have those website names that aren't quite super legit sounding. Instagram posts do not count as a source. TikTok videos do not count as a source. I know you guys are like maybe saying like I would never use Instagram or TikTok as a source, but I am an LA, which is I guess like a Rutgers undergraduate teaching assistant. And yeah, I legit had somebody try and cite a TikTok video and I had to explain why you cannot cite a TikTok video, unless maybe I would say if it's from somebody accredited. But yeah, your Aunt Linda that also almost made it into medical school is not a good source. So, make sure that wherever you're getting your information, if you want to make a claim, have reasonable people to actually back that up. Doctorates, experts in the field, et cetera, et cetera. All right, we can do the next slide. Okay. Also, when you're going through the data, I mean, we're pretty legit, I'd like to think, but don't just take it at face value. We could be super tricking you for all you know, right? So questions you should ask yourself is this data indicative of the entire population? Like we said earlier, right? Like if you have a 30-year-old dude that smokes a lot and he's married and he works in a government job and every single 33-year-old that fits that description has a brain stroke, that doesn't necessarily mean that every 33-year-old in the country that fits that description is also going to have a brain stroke. So you can say, based on the data, we found this, and maybe that actually does line up with the US population. Maybe it doesn't. Like if you find that 10% of the people from the data set have a brain stroke every year and 10% of the US population does, they don't, because that's crazy high. Like that's also a really good thing to note. If you're running multiple hypotheses, make sure that you're doing multiple hypothesis testing. There's a lot of great resources about online, but basically multiple hypothesis testing just kind of weeds out the possibility that you're getting good p-values by chance. So if you've done Data 101, and Malinsky loves to have multiple hypotheses around now in this semester, I think you can also just Google it. It's super, super easy, very quick. But having something like that in your presentation, hey, we know that we're running multiple hypotheses and we are, combating that with this multiple hypotheses test, that's going to look really, really good. Might you need to use different tests for p-values? So like we kind of talked about earlier with like the Shapiro-Wilkinson, qualitative values or things made on a qualitative scale, like very often, sometimes never, those actually may require a different p-value test than the ones you're normally used to. So look into that. And also make sure that you address, why do we care about this? So what's the big deal, right? Like, why are we making you guys look at this brain stroke prediction data set? Definitely do it on like, for the health of the nation, the future of the country, et cetera, et cetera. You can say, and like, I'm not saying don't say it, obviously correlations and equal causation, but you can say like, hey, there were more lethal strokes in rural areas than in urban areas. That's really bad. We need to, start having more funding for hospitals in rural areas or something like that. But yeah, next slide. Oh, I think that's actually the end of the presentation. So cool. Does anybody have any questions? I think there's a note, Tom, but you can stop sharing your screen if you want. All right, cool. So that was pretty much it. If you don't know R, or you haven't learned R, or you haven't downloaded R, highly recommend looking up some YouTube tutorials. Also, Codecademy is a great resource. Also, just to draw attention to our wonderful Discord yet again, we do have a spot specifically in the Rutgers data science Discord to be like, hey, I'm confused, can you help me? You can do that in like #general or #competitions, or better yet, like #help and tutoring. Great spots to do it. And again, just to sum up for anybody that came in late, make sure that if you make a claim and you kind of want to extrapolate it to the rest of the United States, like try and cite your sources. Like I'm gonna take a gander and say that probably none of us are crazy great brain stroke experts. Oh, okay, thank you, Luke. Have a good one. I'm certainly not. I think a very good portion of you probably aren't even biology majors or public health majors or biomed or pre-med or anything like that. And like, we don't expect you to be. So, make sure you're looking stuff up. But yeah, I think that's all I really have.
I'll just ask some questions to help out the people that end up watching the recording.
Mhm.
So either of you can answer this then. First off, let's see, what packages do you recommend people looking into other than ggplot, which we included already in the slides?
So I would specifically say for data cleaning, tidyverse is highly recommended. We use tidyverse a lot in stat inference. So if you are in data 101 right now and are planning to take stat inference in the future, you're going to be using a lot of tidyverse. It's mostly just used to clean out the data and make sure that you have a correct representation of what you want to analyze. And we linked the tidyverse website down in the chat below. So if you guys want to check that out.
Okay. Another thing, so on our studio, probably would be helpful if someone open a visual Blind. We don't have to. On the top right, there is like an environment section. Could you explain to the audience what is the environment section?
Okay, so yeah, I opened up this slide because I think it's like easier to see. But okay, now if you look at the picture, you can see all 4 quadrants that you would normally see when you open up RStudio. So our top left, we can see the script, the R script I was talking about earlier. So in this R script, you would type in whatever code you want. And that code is actually, it would be saved as a separate file if you want to access it again in the future. Below that is the console, which is, it just runs the code you type in, but it doesn't save that code. So obviously, if you want to save it, just type it back into the script. And whatever you type in the console, and by whatever, I mean whatever variables you declare, that would be saved in this global environment here on the top right quadrant. This global environment saves all the variables you create. It saves the data set you're going to use. It saves any transformations you make to the data set. So if you subset the data set and save it as like a separate data set, that will also be saved in this environment. And highly recommended, obviously do that, but save the environment so that you could access all these variables in the future instead of like having to retype all of that out in the console or having to run it again from the script. This last quadrant, which is below the environment, is just, you could see that it says files, plots, packages, help, and viewer. So the files is just all the files that are linked to your computer. So whatever RStudio is linked to, it'll show those files. The plots are basically all the plots you create. Their images will be shown in this section, and you can obviously go back to previous plots and to future plots. The packages shows you a list of packages that RStudio has that you can obviously access. And then the help center, like I mentioned before, help is where you can check out the definitions for various functions and how to use them. Yeah.
Okay, what else? I had a question on top of my head, but now I'm blanking. Okay, first off, how do you comment on R, and how would you recommend people commenting so that it would be easier for us as the judges of the Datathon to understand what their code is?
Oh, that's a great question. So for commenting on R, you can use a simple hashtag in the line, and that will render anything that you put after that hashtag on that same line to not be a command or an error. And it's a really, really great idea to hashtag, especially, or I guess use your comments, especially if you're working in a group and, you know, for the judges, but especially if you're working in a group, because you can explain what you're doing, why you're doing it, etc. And when you maybe like a couple of years down the line, or your group goes back to look at the code, you guys can remember exactly what you're doing and why. Obviously, it also helps us so we can see your thought process as we, you know, score you.
Yes, a hint for if you're planning on submitting your code as a PDF, please comment so we can see what each line of code means. If you just put like a set of code, it's going to be all over the place and it'll be kind of hard for us to understand. So maybe after every line, just be a small comment, hashtag, whatever you guys want the code to do, so we know. If you're putting your code on the PPT itself, we expect an explanation in the PowerPoint, so we're hoping that accounts for the code you're also putting.
Okay, so I guess I'll just ask questions now relating to like how to actually observe the data set on R. So yeah, so first off, so let's say I just downloaded the data set. How do I get the data set onto R so that I can actually view it?
Well, you can use, if you download it as a CSV, then you can just do read.csv and then put your file path to your to the CSV that has the data set. And if you download it and it goes to Excel, you can download the read Excel package and then use read Excel to read the data set. Once you actually have the data set in with your file path, you can do head, the command head, and then look at your data set by doing head and whatever variable name that you save the data set to. And that should pull up the first couple lines of your data. One thing I definitely recommend is if you haven't done that before, like loading in your data set, or you're super confused when I say file path, absolutely look up a tutorial on how to load your data into R, because it makes way more sense when somebody's walking you through it step by step.
Okay, and what if I only want to look at just one specific column of a data set? I don't know if the question is clear enough. If you want, I can answer it myself, but.
Sorry, give me one second.
Do you mean like
yeah, you
The
can
dollar sign.
You can do like the data $sign and then the name of the column to pull up that column. Sorry, my roommate just came in.
Yep. And yeah, just to clarify for anyone, when you put in the dollar sign, it will usually suggest you the different columns. So in case one of the columns has some weird name, you don't have to like remember every single character in it. There's like suggested options.
I put all these functions in the chat. I'll also add these functions to the PowerPoint before we share it to you guys.
Let's see. Is subsetting too complex or?
So, sorry, did you have another question besides?
No, I'm well, this is the question from eBoard to eBoard. Is subsetting too complex to ask a question on?
I mean, it's just gonna be a lot of like talking. If you have questions about subsetting, I would probably just look it up.
Yeah, subsetting is quite complex and there's many different ways to subset. If you have any questions on that, yeah, like Alice said, you'll probably be able to just look up a specific question online, just be like, how do I subset a column based off other columns? How do I subset based off rows? There's a whole bunch of different ways. If you can't look it up, you can always ask on the Datathon Discord, and hopefully one of the eBoard members will be available to answer your question. But yeah, there's a lot of ways to subset. I guess, yeah, okay, well, this is simple. How do you declare a variable?
You can come up with your variable name. I recommend going with something that's easy to type and not mess up. So instead of brain stroke prediction dataset DSE Datathon 2022, maybe go with something simple like data or BS_data. And you can come up with your variable name like that. And then you can use either an arrow or sorry, or the equal sign to assign your variable like that with whatever command you choose there.
I'm gonna share my screen once. I mentioned this in the presentation. So here I could use like a vector as an example. but here I am declaring the variable x. So if you look at next to vector, so I'm declaring the variable x as a vector of the numbers 1, 2, and 3. And so in order to declare this variable, as Ella said, you set it set an arrow, or you could also use the equal sign. And then I just put whatever I want to declare the variable as. In this case, it would be a vector of these numbers. You could also do a string. You could also set it as just a random number. You can honestly set it as anything. But yeah, that's basically how you would declare it.
Do you have any other questions?
Oh, okay. What should I do if I'm writing the code and like the red squiggly like error thing shows up under one of the lines or under some words or whatever?
LOL, just kidding.
What?
I said kidding, but not really. You can always head over to Stack Overflow. Something else you can do is right click on it. Sometimes if I type in something wrong and I right click, I'll get a "did you mean?" or "this error" is usually common. If you're typing in something that's a command and it's still coming up wrong and you're saying to yourself, I know that's a command, double check to make sure that all of your packages and libraries are downloaded. And of course, make sure to check that you spelled everything right. That's the usual checklist I go through. Stack Overflow, by the way, usually comes last in that, not first. But
I know a common error for me is just like having an extra parentheses or missing a parentheses, and that causes all the code to get messed up. So yeah, just make sure that you're not the parentheses aren't messed up. Actually, here, why not? Like what is an integer and what is a float? I guess, why not?
an integer is a number.
I don't, does R have floats?
I mean,
I don't
like
I don't know.
like I mean, but like also
R,
oh yeah, go for it.
okay, so an integer is basically a whole number, not decimal points. So like I mentioned before, if you do round, R usually rounds the decimal number down to an integer, like the closest integer. So R actually doesn't have floats. I think floats is like,
I think R uses
Probably-
single precision. But like most things in R are under double precision, which is basically just kind of, you know.
And in that case, the floats is a sneak peek to the Python workshop tomorrow.
yeah.
In that case, I think we're good, unless
Kidding.
either of you can think of any off the top of your head questions.
I think I'm good. Krish, do you have any questions? All right, no. In that case, I'm going to stop recording. So say goodbye, everybody.
Yes.